Yes. Okay. So yes, so this is a board. Now, see, there is sodium. Sodium belongs to group 1. If sodium belongs to group 1, what does it mean? It has one valence electron. One valence electron means its valence shell, its last shell contain one electron. And sodium is a metal and all the elements are electropositive. All the elements are electropositive. Means during reaction, it will donate one electron. It is going to lose one electron. And when anything loses electron, when any element loses electron, it usually become a positive ion. So sodium, being a metal, it will lose electron and it will become positive ion. I mean, I am telling you that sodium is going to donate its electron to other element. I am telling you about the future of sodium. So what I'm telling you that sodium is going to have +1 charge because it is going to lose one electron. This is the future of sodium, means whenever sodium will react, it is going to lose one electron. It will become positive ion. I mean, sodium will get +1 charge over it. This +1 is the valency of the sodium. This +1 is the valency of the sodium, means in future, sodium is going to donate one electron, a sodium is going to lose one electron, and it is going to be a sodium positive ion. This is the valency. For example, let's take one more, like sodium, sulfur. Sulfur is usually represented with the symbol S. So sulfur belongs to group 6. Group 6 means it has 6 valence electron, not the total electron. The valence electron are 6, means its valence shell contain 6 electron. Okay, so after the reaction, sulfur is going to lose 6 electron? No, because sulfur is a non-metal. Non-metal are electronegative. What does it mean? Electronegative means sulfur will not lose its electron. It is electronegative, means it can attract electron toward itself. It can gain electron. So it already have 6 electron in the valence shell. It need 2 more electron. So after the reaction, sulfur will gain 2 electron to complete its valence shell. It is gaining 2 electron. It is gaining 2 negative electrons, means it is gaining 2 negative charges. So sulfur is going to be a -2. Sulfur is going to be a -2. Okay. Next thing. uh, this is the valency of the sulfur. I mean, what is the valency of the sulfur? -2. Means whenever sulfur will react, it will become -2 ion. This is the valency. Valency usually tell you about the future of element, means whenever sulfur or any element is going to react. So this is the valency of this element and it is going to react like this. For example, the valency of sulfur is -2, means whenever sulfur will react, it will show its negative valency. I mean, it will accept 2 electron. But there is one issue. We have different compounds of sulfur. Sulfur is not -2. This is future prediction for the sulfur. I am telling you about the future of sulfur, that whenever it will react, it will become -2 ion. But sometime, I mean, this is a future prediction now. It may not be correct sometime. Sometime sometimes sulfur is making bond with other element, but it is not accepting electron. It is sharing electrons sometime. It depends on it depends on the element with which sulfur is going to make a bond. So at that time, sulfur would behave a little different, means it may have a positive valency, or you can say it may have +2 valency. The other element with which sulfur is making bond, there is a possibility that other element is attracting electron of the sulfur. So in this case, sulfur is not going to gain electron. Sulfur may have some positive valency, +2, +4, +6. For example, sulfur is making bond with the oxygen, like this is sulfur dioxide. So we know very well oxygen belongs to group 6, means it has -2 valency. I will let you know in a while that how you have to learn the valencies. Okay, so oxygen already has -2 valency, and I am sure about the sulfur. I'm sure about the oxygen that it has -2 valency. So what about sulfur? If you say, Miss, sulfur also has -2 valency because you just told me. But see, how can it possible that two negative particles are making a bond? It means sulfur is not -2 here. Sulfur must be positive here.
But Miss,
Now,
how am I supposed to know that?
yes, I'm just telling you that how to calculate it. I'm just telling you. See, I mean, right now we are sure about the oxygen that is -2, but we have doubt on the sulfur, that sulfur might be positive here. What does it mean? Sulfur is not following its future prediction. Sulfur is not following its valency, which is -2. Sulfur has another valency right now, you can say. So the current valency, I mean, the current situation, I mean, in easiest word, you can say what sulfur is doing right now in the compound. If it is showing its +2 valency, if it is showing its +4 valency, or if it is showing its +6 valency, so that is not the valency. That is the oxidation state now. Just for you, I can say that. I mean, just to make topic easy, I can say that the current valency is called oxidation state. I mean, what sulfur is doing right now, that is its oxidation state, not the valency. So, I mean, valency is -2, but right now sulfur is not -2 here. So, how can we calculate that? What is the
But Miss,
valency of
how am I
sulfur?
supposed to know that it's 2 or 4, the
Yes,
valency?
yes, you have to calculate it. See, I mean, now that is not the valency. That is the oxidation state. Now that is not the valency. That is the oxidation state. Because sulfur, I mean, the valency of the sulfur is fixed, which is -2. But sulfur is not following its valency. It has different valency right now. And that is not the valency, that is the oxidation state. So how can we calculate the current valency, current oxidation state of the sulfur? So see, sulfur, I mean, we have to calculate the oxidation state of sulfur. So you have to write S plus oxygen. I mean, in this compound, we have two elements, sulfur and the oxygen. There is one sulfur. Okay. How many oxygen are there? Two oxygen. You can write two here. You have to make it equation equals to 0. According to the mass, you can make it equation equal to 0. Okay. What I did here, I just have broken the compound into two portions, sulfur and oxygen. Sulfur plus oxygen. But there are two oxygens, so I have to write 2 with the oxygen. Keep in your mind, this 2 is multiplying with the oxygen. Okay. So actually we have doubt on sulfur, but we are sure about the oxygen. So we can solve oxygen here. See, sulfur as it is. Instead of sulfur, you can write X also. X means unknown. Okay. Plus 2 as it is. Oxygen. Oxygen is, what is the valency of oxygen? You have to put it here. The valency of oxygen is fixed, -2 is equal to 0. Sulfur plus minus, 2 and 2 are multiplying with each other. So plus minus 2 multiplied by 2, 4. I am following the algebraic rules, is equal to 0. This is -4. So when you shift -4 toward the right side, it will become +4. See, sulfur is equal to +4. It means sulfur is +4 in this compound. Sulfur has +4 valency right now. So this is called oxidation state of sulfur. Means +4 is telling you that what sulfur is doing right now. I mean, its 4 electrons are attracted by the oxygen. Usually sulfur is electronegative. It has to gain electron. It has to attract electron to it itself. But according to the bonding chapter, according to chapter number 4, we have already done. According to the bonding, uh, oxygen is more electronegative. More electronegative means it has more power to attract electron. So sulfur cannot attract the electron of oxygen. Actually, oxygen is attracting the electron of sulfur right now. So oxygen is showing its negative valency here, and sulfur, you can say the electrons of sulfur are attracted by the oxygen. Sulfur will become positive because its negative charges are moving toward the oxygen. So sulfur will be positive, but we don't know the valency of, we don't know the positive valency of sulfur. We know that sulfur has a valency which is -2. We know this one, that sulfur has valency which is -2. That's what we know from the chemistry. So the valency of sulfur will be -2 all the time. But here, sulfur is not -2. What does it mean? It means sulfur is showing some other valency, some other oxidation state. So you have to check the current situation of sulfur. I mean, you have to check the current oxidation state of sulfur, that what sulfur is doing right now. So we are sure about the oxygen. So that's what we just did to find the oxidation state of sulfur. For sulfur is one of the confusing element. Let me show you. For example,
But
say,
Miss, I got this, but how am I supposed to go, like, what type of questions gonna come and how am I supposed
no,
to
no.
write that?
Uh, basically,
Paper.
uh, basically, this is a part of a question. I mean, they will give you an equation. They will give you an equation. There will be, for example, nitrogen and hydrogen together. They are giving you ammonia. So you have to check whatever is getting oxidized and whatever is getting reduced. So you have to check their oxidation state sometime if they are not following their valency. Let me show you. Um, for example, yes, magnesium Mg plus O2, and together they will give you magnesium oxide. Okay, now you have to check whatever is getting oxidized here and what is getting reduced here. So how can you check it out? You have to check their oxidation state, not the valency. Oxidation state is the current situation. The current situation. See, this magnesium is alone here, monoatomic. The magnesium is alone here, means the monoatomic. What magnesium is doing right now here? Nothing. It is alone. So what is the oxidation state? Zero. Because magnesium is not attracting electron from anywhere. It is alone here. It is alone here. So it is not attracting electron from anywhere. It is not giving its electron right now. It is neutral and it is alone here. So what is the oxidation state? Zero. This is O2 molecule. What is the oxidation state? Zero. For the monoatomic and for the diatomic molecule, oxidation state is zero. I mean, the current situation of oxygen, what oxygen is doing? Oxygen is not giving its electron to anyone right now. Oxygen is not gaining electron from anywhere right now. It is sharing electron with another oxygen only. It is not gaining or losing electron. So oxidation state is zero. All the monoatomic elements, monoatomic means single atom, like magnesium alone, they have zero oxidation state. All the diatomic means anything which is made up of two similar atoms, that has zero oxidation state. So see, oxidation state is 0, 0 for both. Now move toward the product side. Magnesium oxide. Magnesium is making bond with the oxygen. How it is making bond with the oxygen? So you have to check your periodic table. Where is magnesium in the periodic table? Magnesium belongs to group 2. Group 2 means it has 2 valence electron. If it has 2 valence electron, means it is going to lose 2 electron. So if it is losing 2 electron, it will become +2. What about oxygen? Oxygen means oxygen belongs to group 6. It has 6 valence electron. It can gain 2 electrons. So see, magnesium is losing 2 electrons. So definitely those two electrons will be gained by oxygen. So oxygen will be -2 here. Now see what is happening with the magnesium. Magnesium, the oxidation state of the magnesium was 0, and after the reaction it is becoming +2. And what about oxygen? Oxygen had oxidation state 0 before the reaction, and after the reaction it is becoming -2, means the oxidation state of magnesium is decreasing from 0 to -2. Is there any confusion till now?
No, Miss.
Okay, so see, magnesium 0 and 0 to +2. Oxidation state increasing. 0 to +2, 0, +1, +2. So this is the oxidation state of magnesium before the reaction, and after the reaction +2. Magnesium, oxidation state is increasing. For the oxidation state was 0 before the reaction, but after the reaction it is -2. Oxidation state is decreasing. So you can see these two things. I mean, for the magnesium, there is increase in oxidation state. For the oxygen, there is decrease in oxidation state. Increasing oxidation state is called oxidation. Decreasing oxidation state is called reduction. Increasing oxidation is called oxidation. And decreasing oxidation state is called reduction. This is called oxidation reduction. But these are only two definitions right now. Oxidation and reduction. I mean, we have different definition for oxidation and reduction. You can say we have different tricks to check if there is oxidation or reduction. Right now, see, in terms of oxidation state, you can say that if the oxidation state is increasing, if the oxidation state is increasing, it means there is oxidation. You can see for the magnesium, oxidation state is increasing. So magnesium is oxidized here because increasing oxidation state is called oxidation. For oxygen, oxidation state is decreasing, and decreasing oxidation state is called reduction. So you can say that magnesium is getting oxidized, oxygen is getting reduced. At magnesium, there is oxidation. Magnesium is getting oxidized because the oxidation state is increasing. What is the oxidation state? Current situation. What element is doing right now? So magnesium was not doing anything before the reaction. You know, magnesium is not making any bond at the reactant side. So it was alone. It was resting alone. So what is the oxidation state? Zero. It is not attracting or it is not gaining or losing electron before the reaction. Zero. After the reaction, it is losing 2 electrons for the oxygen. So it is becoming +2. Losing electron will give positive charge. Oxygen, oxidation state is decreasing. What does it mean? -2. Is there any confusion? Okay, let's move to PPT now, because we have a document with which we could discuss. See, now see, oxidation. Oxidation means oxidation state is increasing. We just discussed the example. Of the magnesium and the oxygen. Magnesium was having 0 oxidation state before the reaction, and after the reaction, it was having +2 oxidation state. So there is a possibility that any element may have -4 oxidation state, and after the reaction, it may have +2, +3, 0, -1. But if the oxidation state is increasing after the reaction at the product side, I mean, you have to compare reactant side and the product side together. So you have to check what element is doing at the reactant side, alone or diatomic, 0 oxidation state. If element is making bond at the reactant side also, then you have to check its oxidation state. But at the product side, there will be different oxidation state. And just because of the difference in oxidation state, you can find either there is oxidation or reduction with that element. So if the oxidation state is increasing, oxidation. If the oxidation state is decreasing, reduction. Okay, so yes. First of all, you should know what is oxidation and what is reduction. Wait, let's start with the basic definition. Yes, so what is oxidation? Oxidation and reduction. Oxidation means, okay, the name shows gain of oxygen is called oxidation. But you know, oxygen is not involved in every reaction. So we do have some other definition for oxidation also. I mean, in case of this reaction, you can see there is oxygen involved. So you can say that gain of oxygen is called oxidation. So magnesium is gaining oxygen here. So you can say that magnesium has been oxidized as it has gained oxygen. But you know, there are different reactions in which oxygen will not be involved. Then you have to check oxidation state, like we just discussed. If the oxygen is not involved, then you have to check the oxidation state of the element so that you could easily find if the reaction is, I mean, if there is oxidation or the reduction. Okay. Next one is, wait. So what is oxidation? Gain of oxygen is called oxidation. But I just told you that Oxygen is not involved every time. So we have one more definition. We have one more definition for oxidation. And the definition is removal or loss of hydrogen. You can see what is this? C2H5OH. This is an organic compound. This is a compound which we have discussed in organic chemistry. This is ethanol, alcohol, ethanol. Okay, so you can see ethanol had 5 plus 1, 6 hydrogen. And after the reaction, see, it has 3 plus 1, only 4 hydrogen. Sorry, we have to focus on hydrogen here. So C2H5 and OH, this is ethanol. See, there are 5 plus 1, 6 hydrogen at the reactant side, and see at the product side, ethanol is losing hydrogen. 2 hydrogen have been separated here. So ethanol has lost some hydrogen. See, 3 plus 1, 4 hydrogen. And before the reaction, it had 6 hydrogen. So losing of hydrogen is also called oxidation. So oxygen will never be involved in all the reaction. I mean, whenever there is oxygen, so you can check if something is gaining oxygen, so you can say there is oxidation. So simple. But if there is no oxygen, then you can check for the hydrogen. If something is losing hydrogen, means oxidation. This is so simple. Okay. Reduction. Gain of hydrogen. Loss of hydrogen is oxidation. You know, oxidation and reduction both are totally opposite to each other. They are exactly opposite to each other. We just discussed that oxidation is actually loss of hydrogen, and C reduction, gain of hydrogen. So what is this? C2H4. C2H4 is C2H4 is, you can draw it. This is ethene. You can try to draw a C2H4. You will get double bond between 2 carbon. So this is ethene. And this is hydrogen gas. See, ethene had 4 hydrogen before the reaction, and after the reaction, it has 6 hydrogen. Ethene is gaining hydrogen here. Gain of hydrogen is called reduction, because loss of hydrogen is oxidation. So gain of hydrogen is reduction. Simple. Let me tell you one more thing here. Which type of reaction is this? We have already done this reaction in organic chemistry. This is ethene, alkene, and we are adding hydrogen gas into ethene, and we are getting some ethane, means this is ethane now, means alkane. Ethene plus hydrogen is giving you ethane. This is the addition reaction of alkene. We are adding hydrogen gas into the alkene. And if you want to go more specific, so this is hydrogenation of ethene, which is giving you ethane. So this is reduction. But we have one more definition for the reduction, because you know, hydrogen will not be involved in every reaction. So we have one more definition, and that is in terms of oxygen. See, gain of oxygen is oxidation. So loss of oxygen is reduction. You can learn you can learn the definition of oxidation only. Reduction is exactly same. Okay, so see, this is copper oxide. Copper is a transition element. This is copper oxide. Okay, copper oxide plus hydrogen gas. Copper oxide plus hydrogen gas, and that is giving you copper plus H2O. So copper had oxygen before the reaction, and after the reaction, it doesn't have any oxygen. So copper has lost oxygen, and loss of oxygen is called reduction. Okay. Yes. You have to check these reaction and you have to check where there is oxidation. Okay. See, lead oxide, PbH2, lead oxide. Lead oxide is reacting with the hydrogen gas.
Yes, how am I supposed to know that PbO means?
You have to practice for that. You have to practice for that. You have to check the
Yes,
periodic table that what is yes, 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 yes.
nothing, miss. Like I was asking from where.
Okay, and now periodic table. You have to check. Balki, there is one issue in periodic table. They will not give you names. You have to learn the name. I mean, you have to learn symbols and names separately because they will give you a periodic table in which only these symbols will be given. So you should know that Pb is a lead. I mean, C for carbon. This is so simple, but in case of lead, we are not using L for the symbol of the lead. There is Pb. Pb means lead, and there is oxygen. And the compounds of oxygen are called oxide, carbon dioxide, sodium oxide, magnesium oxide, sulfur dioxide. So this is lead oxide, and this is hydrogen gas. That's why I told you that you just try to practice some O levels past paper, or try to buy past paper of uh, O levels, or try to buy some books of O levels so that you could do some practice from O levels books, because you haven't done chemistry in O levels and this is the basic of chemistry. So you can Google this whole stuff also. I mean, this is available on the Google also, that there, I mean, Pb is the symbol of lead. So you should learn the name and the symbols so that you could work on the equations. So this is lead oxide and the hydrogen gas. And see, after the reaction, there is no oxygen with the lead. There is oxygen with the lead before the reaction, and after the reaction, there is no oxygen with the lead. It means lead is losing oxygen. Lead is losing oxygen. So lead is getting reduced here. And hydrogen is gaining oxygen. So hydrogen is getting oxidized here. Lead is getting reduced because lead is losing oxygen here. So lead is getting reduced. And hydrogen, it is gaining oxygen from the lead. So you can say that hydrogen is getting oxidized. Lead reduce, hydrogen oxidize. In a second example, see, carbon monoxide has one oxygen, and this is Ag. Ag means silver. This is silver oxide, and silver oxide is also having one oxygen. And after the reaction, silver doesn't have any oxygen. Means silver is losing oxygen. Silver is getting reduced here. And what about carbon monoxide? See, it has gained one oxygen. So it is gaining oxygen. So carbon is oxidized here. Carbon is oxidized here. See, carbon is gaining more oxygen and silver is losing oxygen. Silver is reduced here. So this is so simple. And check the other one. Actually, you just have to check whatever is getting oxidized here, but I have told you about the reduction also. Because if one is getting oxidized, so other one might be reducing. See, iodine has, this is I for iodine, this is carbon monoxide. See, iodine has two oxygen, and after the reaction, iodine doesn't have any oxygen. Iodine has lost oxygen, reduced. Carbon has gained oxygen. Carbon has one oxygen before the reaction, and after the reaction, carbon has two oxygen. So carbon has gained oxygen. So carbon oxidized.
So, what to write? Is the answer?
They are asking you that you have to tell them which reactant has been reduced. So yes, so iodine is reduced here. Iodine is
I just
reduced
have to
here.
write.
Yes, iodine. Iodine is the answer. Iodine is reduced here because iodine has lost oxygen. In second case, sulfur has oxygen. Oh, wait. Yes, sulfur has two oxygen, and after the reaction, sulfur doesn't have any oxygen. Loss of oxygen is called reduction. So sulfur is getting reduced here. In first case, iodine has lost oxygen, so iodine is getting reduced here. And in second case, sulfur has lost oxygen, So sulfur is getting reduced here. We are checking oxidation and reduction in terms of oxidation and reduction only right now. See, there are more definition for the oxidation and reduction because you know oxygen and hydrogen both will not be available in every reaction. I mean, there is a possibility, no, that a few reactions have oxygen in it and few reactions have hydrogen in it, but there are few reactions which do not have hydrogen and oxygen both. Then how can you check if there is oxidation, or how can you check there is reduction? For example, sodium is reacting with the chlorine gas. There is sodium and the chlorine which are going to give you NaCl, no oxygen, no hydrogen involved. So how can you check if there is oxidation and reduction? That's why we have more definitions. And this is, see, oxidation and reduction in terms of electrons. What happened when you react something? So definitely one would be losing electron, other one would be gaining electron. That's why we are doing reaction. That this is how we do reaction actually. So in terms of electron, I mean, if the oxygen and hydrogen both are not involved in the reaction, you can go for electron. You can check number of electrons which are being lost or gained, and you can check what are which element is losing electron and which element is gaining electron during this reaction, during the given reaction. So see, oxidation, removal or loss of electron. These are the codes, oil and rig. These are the code words, and you can say these are the trick words. This is a trick to remember oxidation and reduction in terms of electron. Oil means O for oxidation, I for is, L for loss. Oxidation is loss. Reduction is gain of electrons. So these are the code words you can say. So oxidation is oil, means oxidation is loss of electron, and reduction is gain of electron. Okay. So oxidation means a species will get less negative or more positive. Species will get less negative or more positive. Means any species which is losing electron, it will become less negative or more positive. Forget about this stuff. I mean, forget about this line. It will confuse you a lot. We don't need this line. Just remember one thing. Oxidation is loss of electron. You don't have to go in this much detail. We are not going to discuss that if something is becoming more positive or more negative. Forget about that thing, because we have already discussed one thing, and that is oxidation state. Increasing oxidation state, oxidation, decreasing oxidation state, reduction. So you don't have to focus on this line. You will get confused. Simple. Oxidation. Loss of electron means oil, or oxidation is loss means loss of electron. Reduction, reduction is gain of what? Electron. So what is redox now? Wait, we just discussed that if during any reaction, if something is gaining oxygen or losing hydrogen, or it is losing electrons, or if the oxidation state is increasing, so we can say there is oxidation. If something is losing oxygen or gaining hydrogen, or if the oxidation state is decreasing for something in a reaction, or if something is gaining electrons, so we can say there is reduction in that reaction. But when reduction and the oxidation both take place in one reaction, we call it redox reaction. Redox reaction is that reaction in which you can see reduction and oxidation both. I mean, one is getting oxidized and other one is getting reduced in a same reaction. It means that is a redox reaction. And you know, all the reactions are redox reaction. All the reactions are a redox reaction because in every reaction, if one is losing electrons, so other one must be gaining electron. See, losing electron oxidation, gaining of electron reduction. So in every reaction, there will be oxidation and reduction both. That's why that reaction is called redox reaction, in which you can see reduction and oxidation both. Is there any confusion?
No, miss.
So this is all about the basic of oxidation and reduction. We have already discussed one more example of oxidation and reduction, one more definition of oxidation and reduction, that is increasing oxidation state and decreasing oxidation state. And this one is more easy. I mean, if you can